On April 29, 2019, the Parkes Radio Telescope in Australia began listening to the radio signals from the Sun's nearest neighbor, Proxima Centuri, just over 4 light-years away. The telescope was looking for evidence of solar flares and so listened for 30 minutes before retraining on a distant quasar to recalibrate and then pointing back. Today we will discuss with you why a signal that appeared to come from Proxima Centuri almost certainly didn't. Welcome back to Signature's Life, and you're watching Signature's Science. In total, the telescope gathered 26 hours of data, but when astronomers analyzed it in more detail, they noticed something odd. A single pure tone at a frequency of 982.02 MHz that appeared 5 times in the data. But researchers have consistently played down this possibility, saying that, at the very least, the signal must be observed again before any conclusions can be drawn. Indeed, the signal has not been seen again, despite various searches. They have calculated the likelihood that the signal came from a Proxima Centuri-based civilization, even without another observation. They say the odds are so low as to effectively rule out the possibility, provided the assumptions they make in their calculations are valid. The new signal was found by researchers at the Breakthrough Listen project. The signal is interesting because narrowband tones do not generally occur in nature, which instead tends to produce broadband noise. Before, the most likely origin is Earth. Most signals of this kind are quickly attributed to radio interference from nearby mobile phones, microwave ovens, passing cars, aircraft and satellites, and the like. But the team analyzing this signal have yet to find an obvious source, and they say the frequency of the signal drifts slightly over time, a phenomenon consistent with a signal from a rotating or orbiting body. This has increased the intrigue. Their approach is based on the Copernican principle, the idea that the Earth has no privileged place in the universe and is at no special time, so that observations made from here are no more unusual than observations made anywhere else in the universe. This principle has a storied past. It is named after the 14th century astronomer Nicholas Copernicus, who suggested that the Earth did not sit at the center of the universe and instead orbited the Sun. Almost 30 years ago, the astronomer Richard Gott used the principle to show with 95% confidence that our species is likely to survive for at least 200,000 years, but no more than 8 million years. The basic idea is that humanity had a beginning and will eventually come to an end. We currently sit somewhere on the timeline in between, but at no special place or time, no particularly near the beginning or the end. In mathematical terms, we are unlikely to be in the first 2.5% of the humanity's existence, nor in the final 2.5%. So with 95% confidence, we must be in the middle. Then it's just a question of slotting in the numbers. We know our species is about 200,000 years old, which must be at least 2.5% of the total. That suggests with 95% confidence that humanity should be around for at least another 200,000 years, but no longer than 8 million years. Scientists suggest that the chances of finding evidence of intelligent life elsewhere in our galaxy is tiny, even if we assume that these civilizations must exist. Given that we have only been radio capable for just over 100 years, the chances of this period overlapping with another civilization's similar capability is tiny. Indeed, given the huge number of potentially habitable planets in the galaxy, the idea that 2 neighboring stars should host advanced civilization at the same time seems extraordinarily unlikely, unless there are other factors at work. One such factor is panspermia, the idea that life is seeded from space, that increases the chances of neighboring stars hosting advanced life at the same time. However, this argument is complicated by the fact that life emerged on Earth some 4.5 billion years ago before the Sun and Proxima Centuri became neighbors. Of course, the Copernican principle cannot rule out entirely the possibility that the signal heard at Parkes is from another civilization. It's just that the possibility of it being a stray signal of terrestrial origin are many orders of magnitude more likely. In the meantime, all astronomers can do is point their radio telescope back at Proxima Centuri and wait.